This is part 3 of topic 1, demand and supply, and what we're looking at in this topic is something that's very closely related to the demand and supply model, that is various measures of elasticity. So we are looking at the price elasticity of demand and the income elasticity of demand. The other two that you have to learn about are the cross-price elasticity of demand and the elasticity of supply. So the logic in me just covering two of these four elasticities is that by covering two of them, I should give you enough of an insight into what an elasticity is for you to fully understand cross-price elasticities and the price elasticity of supply. Right at the end of this topic, we will be going through a case study related to Cyclone Yasi and the effect of that cyclone on banana crops in Queensland. So moving on to the next slide, we've got a demand curve. First thing we have to figure out is what the price elasticity of demand actually measures. Well, it measures the sensitivity of the relationship between price and quantity demanded. So let me give you an example. If we were considering the market for apples in Perth, and I said to you something such as, if the price of apples goes up by 20 cents a kilo, the consumption of apples will drop by 20,000 apples per week in Perth. It would be very difficult for you to come to terms with whether that was a very big response or a very small response. However, if I said to you, if the price of apples goes up by, say, 10%, the consumption of apples will fall by 20%, then you've got a sense that that is the demand for apples is very sensitive to a change in price, because prices are going up by 10%, but quantity demanded are dropping by 20%. So that's a very sensitive commodity that we're talking about here. That's exactly what the price elasticity. That's exactly what the price elasticity of demand looks at. The sensitivity of quantity demanded to a change in price measured in percentage terms. And we measure the elasticity in percentage terms because it gives us a better feeling of what is sensitive and what is insensitive in terms of quantity demanded. So from your reading of the relevant chapter in the textbook, you would have realized that along a demand curve, the price elasticity of demand does actually change. So high up on the demand curve, where we're dealing with very large prices but small quantities, the price elasticity of demand is generally greater than 1, and on the bottom of the demand curve, the price elasticity of demand is less than 1. So we have this feature where the price elasticity of demand actually varies. Now the reason that it varies is as follows. Let's consider points high up on the demand curve, so at prices of around about $12, $13 a unit. If we start up high on this demand curve at a price of, say, $13, and we lower the price by $1, then in percentage terms, that is going to be a very small percentage change in price. At the same time, as we lower the price from $13 down to, say, $12, we're going to get a very big percentage change in quantity along the horizontal axis. So, for example, quantity may have started off at 20 units, but it'll increase to, say, 30 units. Now, that is a 10-unit increase from 20 to 30, but in percentage terms, that's a 50% increase. So high up on the demand curve, the percentage change in quantity demanded when you move along the demand curve is very large, simply because the initial quantity is very small. At the same time, the percentage change in price is very small because the initial price is very large. Now, the definition of the price elasticity of demand is the percentage change in quantity demanded over the percentage change in price. So high up on the demand curve, if we move along the demand curve, we're dealing with very large percentage changes in quantity demanded and very small percentage changes in price. So because the percentage change in quantity demanded is large and the percentage change in price is small, we are going to have very high or large elasticity values high up on the demand curve. So the response of quantity demanded to a change in price along this demand curve is constant in levels because it's a linear demand curve. So for every dollar that price falls, maybe quantity goes up by 5 units. It's a constant response in terms of the level of prices and the level of the quantity. But in percentage change terms, the size of the response does vary along the demand curve. Okay, so what I've got here is a very simple example. There was a running race held in California a number of years ago, and it was held in 1999 initially. The entry price to the race was $12, and they had 1,600 competitors enter the race. It was run again in 2001. The price was raised to $20 because of the success of the race in 1999, and there were only 900 competitors. So what I've done is I've put a demand curve through these 2 points, and I've used these numbers to calculate the price elasticity of demand. So if you have a look at the formula on this slide, you'll see that at the top, I'm calculating the percentage change in quantity demanded here. So I've got the change in quantity over the base quantity Q1, and that is a percentage change. Just one thing to note though, as the value Q1, if you have a look down at the second line of the formula, I've inserted the value 1250, which is actually the average quantity. So it's the average of 900 and 1600. So what we're actually doing here is calculating an arc elasticity, not a point elasticity. The same with the price. P2 minus P1 divided by P1 is the percentage change in price. I've calculated the percentage change using the average price. So the elasticity comes out at minus 1.12. And the question I've got right down the bottom is this the true price elasticity of demand? Well, to answer that question, let's go ahead to the next slide. And the answer is absolutely not. That is not the correct way to estimate the price elasticity of demand. In going back to this slide, I've made a very bold assumption that those 2 points are on the same demand curve. Chances are they're not. Because they're 2 years apart in time, chances are those 2 points are not on the same demand curve. So to illustrate what I mean by that, let's go ahead to this example. And point 1 in 1999 is 1 point on demand curve D1. In 2001, let's assume that the weather was terrible on the day this race was run. And so fewer people actually entered the race because of the bad weather. So the point 2001 at a price of 20, quantity of 900, that's actually on a separate demand curve D2. So in this example, there's 2 reasons why the number of competitors in this race has fallen from 1,600 down to 900. The first reason is the price has been increased from $12 to $20. The second reason is the really bad weather on the day of the race. Now, of course, when we've got that, it means that that blue demand curve that I drew originally is not a demand curve at all. The demand curves are actually D1 and D2. And it's very difficult to actually separate out what impact the increase in price had on the number of competitors from the bad weather conditions. So I've just kept things nice and simple and drawn the demand curves assuming that I know what they look like, which is a heroic assumption. But the way I've drawn it, I've got the increase in the price causing a 200 unit reduction and the leftward shift in the demand curve causing a 500 unit reduction. Now, in terms of the elasticity that we calculated in the previous slide here, the elasticity, price elasticity, calculates the sensitivity of demand to a change in price along a given demand curve. But what I've actually done in this example, without knowing it, I've tried to calculate the price elasticity not along a single demand curve, but I've tried to calculate the price elasticity between 2 points on 2 separate demand curves. That doesn't work. What I should have done is used the point $20 1400 units and the point $12 1600 units. I should have used those 2 points on the demand curve D1 to calculate the price elasticity. Of course, I don't really know what that point at a price of 20 on demand curve D1 is. I've assumed it's 1400, but I don't actually have that value. I've just made the number 1400 up to illustrate. So hopefully that makes sense, and that shows you the difficulty of calculating these price elasticities, particularly when the 2 points are separated by a large amount of time. In calculating price elasticities, you have to assume that everything else that affects demand, other than price, has stayed constant. And in this example, chances are between 1999 and 2001, a lot of things changed. And so this estimate that we got of minus 1.12 is a completely worthless elasticity. It means it's meaningless. It's not an elasticity value at all. Okay, moving along to the price elasticity of demand and total revenue. One thing that you do have to come to terms with is the relationship between the price elasticity of demand and total revenue. And what you can see here is that total revenue is inversely related to the elasticity value. So when the price elasticity of demand is high and we're high up on the demand curve and we start moving down the demand curve, total revenue at first increases, but then it declines. So I've got quite a bit of explanation on this slide, which should help you understand what's going on here. But just to help you along, let's consider moving from point A to B on the demand curve up here. As we move from A to B, the only way we can do it is to lower price. And when we lower price, quantity demanded will increase. But high up on the demand curve, the price elasticity of demand is actually greater than 1. So when you lower the price and the price elasticity of demand is greater than 1, you get a very responsive or elastic increase in quantity demanded. So if we have to, say, lower the price by 10% to move from A to B, because the price elasticity of demand is greater than 1, the percentage change in quantity demanded is going to be greater than 10%, maybe 15%. So if you're lowering the price by 10%, but quantity demanded is increasing by 15%, total revenue must be going up. And on the bottom diagram, that's exactly what is happening between points A and B. We are increasing quantity by lowering price. But the increase in quantity is larger in percentage terms than the reduction in price, so total revenue goes up between points A and B. The next elasticity measure is the income elasticity, and what I've assumed here is at the top of the slide an increase in income. We very often use Y to signify income. An increase in income of 10%. That shifts the demand curve to the right for a normal good. And I've made up some numbers here, and I've assumed that the level of demand increases from 500 to 520 units. Now that increase of 20 units is a 4% increase. So what I've actually done is, keeping price constant, I've assumed that a 10% increase in income increases demand by 4%. So the income elasticity of demand must be 0.4. Now the challenge for you is you need to understand which goods are likely to have a large income elasticity of demand and which goods are likely to have a small income elasticity of demand. So you can think of it this way: if your income went up by 50%, which goods would you buy a lot more of and which goods would you buy very little extra of? So for me, if you increase my income by giving me a raise of 50%, I would consume very little more fruit and vegetables. So for me, my income elasticity of fruit and vegetables is going to be very, very small. But I would probably consume a lot more luxury items, so holidays, restaurant meals, those sorts of things. So for me, my income elasticity for holidays and restaurant meals is going to be significantly larger than 1. The next slide, we've got a case study, and we've got a situation where we're looking at Cyclone Yasi. For those of you who don't know or don't remember, Cyclone Yasi hit Queensland quite a few years ago now and wiped out banana crops. And because the banana crops were wiped out, production of bananas in Australia really fell substantially. So supply decreased from S1 down to, say, S2, quantity of bananas of 100. Could be 100, 100,000, 100 million. It's just an indicative number, 100. Now, when the banana crops were wiped out and the supply curve shifted to the left, the first thing that happened is that price increased. And we went from the old equilibrium at P1 to the new equilibrium at P2. But the whole point of this case study is getting you to think about why the price is actually increasing. And in this case, why it actually increased so much. Now, I think prior to that cyclone, bananas were selling around about $2 per kilo. But after the cyclone and after the supply curve shifted to the left, prices hit around about $18 to $19 a kilo. So then the question is, why did prices increase so much? Why didn't they just simply increase to $6 or $7? Sort of a tripling of prices or a quadrupling of prices. Why did prices go up by a factor of 8 to 9 times? Well, the intuition behind this case study goes as follows. When the supply curve shifts to the left, price goes up to rebalance the market. But as price is rising, price is not rising simply to reflect the fact that there are fewer bananas available. Price is actually also rising to reduce the level of demand so that demand falls back to 100 units as well. So when the cyclone hit and prices started to rise and they had to go from $2 up to $18 to get the market back into equilibrium, that suggests to me that the demand curve for bananas was very, very steep. It took a price increase of $16 per kilo to actually reduce demand by the amount it needed to fall by to restore equilibrium. So another way of saying the same thing is that in Australia we had to have a significant increase in price before consumers cut back their demand of bananas significantly enough to restore equilibrium. Another way of interpreting that is the demand curve for bananas at that time was probably very steep or highly inelastic. Now, if Australians had have been willing to cut back their banana consumption quite willingly, then the demand curve would have been much flatter and we wouldn't have needed such a large price increase to restore equilibrium in the market. So keep that in mind. When markets are changing like this, in the case of a decrease in supply, price is going up, but the price is going up to actually reduce demand back to the same level as the new level of supply. Okay, so supply falls to 100, demand has to fall to 100 as well. The only way demand can fall to 100 is price rises. And in a competitive market like this, where prices are flexible, the price will certainly keep rising. It'll keep going up and up and up until demand is reduced by the level that supply is reduced by. So that's an insight into the functioning of markets, and hopefully you can take that type of logic and apply it to other examples in this course.